Here this question is asking, given the following two pattern pairs, x1 to y1 and x2 to y2, which are to be stored in a BAM, which is bidirectional associative memories. X1 is equal to 1 1 1 1, y1 is equal to 1 1 minus 1 minus 1, and x2 is equal to 1 minus 1 1 minus 1, and y2 is equal to 1 minus 1 minus 1 1, and the noisy vector to be recalled is xt is equal to 1 minus 1 1 1. So a part, the calculation step of the weight matrix W, and the B part is asking us to find out the calculation step of the steady state recall pattern pair of the noisy input vector xt, and submit your answer for the grade, the sum rounded to 2 decimal places of each of the diagonal elements to the power 2 of your calculated weight matrix W. Okay, so let's see how to do this problem. So here what we have to do is they are saying x1 and y1, x2, y2, these are to be stored in DAM, bidirectional associative memory, these two pairs here. So we have to find out the weight matrix of them. So in order to find the weight matrix, this is the equation we have to use. Weight matrix can be calculated using W, that is equal to summation of k is equal to 1 to k x of k transform yk. Now this k value on top is nothing but, we have to see how many pairs we have. We have x1 y1, x2 y2, we have two pairs of x's, so the k value is 2. And then once we have that, then the next step is we have to do the x transform, and y remains the same, and we have to multiply each pair and add them together. So here this is x1, you see 1 1 1 1, but we do the transform, so whatever the horizontal is going to be vertical, and y remains the same, and then we do the multiplication. Okay, and if you remember the matrix multiplication, if we have this is like we have to look at the row first. We have 4 rows and 1 column. So this is a 4 by 1 matrix, 4 by 1 matrix, and this one is a 1 by 4 matrix. And you see, if these two are matched, we can multiply, and the output will be 4 by 4 matrix. Okay, so we multiply the row by the column first. So if you look at the row, the first row is 1, and we multiply by each column. So 1 times 1 1, 1 times 1 1, 1 times minus 1 minus 1, 1 times minus 1 1 minus 1. So since all of them are 1, we just try to multiply each value and put them in the rows like this, and you are gonna end up getting this pattern. Like this is 1 1 minus 1 minus 1, repeated 4 times because we are just multiplying by 1. And here we do the same thing for the next one. 1 times 1 1, 1 times minus 1 minus 1, 1 times minus 1 minus 1, 1 times 1 1. And if you do the minus 1, sign is going to flip. Minus 1 times 1 minus 1, minus 1 times minus 1 1, minus 1 times minus 1 1, minus 1 times 1 minus 1. Like that, it repeated again. Okay, now we have to add them. When we add the matrix, we have to add the corresponding location. Like if it's 1 1 location, you see 1 and 1 2, 1 plus minus 1 0, minus 1 minus 1 minus 2. Like that we add them, and this is our weight matrix. Now once we have the weight matrix, if you want to calculate the weight, what we have to do is we have to square the diagonal. So if you look at the diagonal, we have 2 2 minus 2 minus 2, and we have to square them and add them together. So here we can see summation of w square, which is equal to 2 square plus 2 square minus 2 square plus minus 2 square, all together that will give us 16. Since the question is asking us to give it in 2 decimal places, rounded to 2 decimal places, we put it as 16.00. Okay, that's the A part of the question. We calculated the weight, and the next part of the B part of the question is asking the calculation steps of the steady state recall pattern pair of the noisy vector input. So we have to recall them using the noisy vector. The noisy vector is given to us, that is 1 minus 1 1 1. Okay, so we bring the noisy vector, that's 1 minus 1 1 1, and we put it in this equation GHXTW. This XT is the noisy vector, that's 1 minus 1 1 1, and W is the weight that we calculated before, the weight we have right here. Okay, we bring this one and multiply each of them. So here you can see this is a 1 by 4 matrix, 1 row 4 columns, and this one is a 4 by 4 matrix, and you see these two are matching, which means we can multiply, and this is going to be the output. 1 by 4 matrix is going to be the output. Now again, row multiply by the column. So how do we multiply? 1 times 2, 2, and then minus 1 times 0, that is 0, and then 1 times 2, 2, and then 1 times 0, 0. So that's going to give us 4, and then you do the same thing for each column. 1 times 0, 0 for the next one, and then minus 1 times 2, minus 2, and then 1 times 0, 0, and then 1 times 2, 2. So if you add them together, that's going to give you 0. So like that, we multiply the row by each column, and that gives us this 4, 0, minus 4, 0. And if you have a GH of this, the thing is, if you have a positive or 0, that replaces 1, and if you have a negative value, that replaces with minus 1. So here you can see 4 will replace with 1, 0 replace with 1. If it's a negative value, it has replaced with minus 1, and 0 replace with 1. Okay, that gives us the YT value. Now once we have the YT value, what we do is we take this weight and do the transform. Transform is like, think of it as like a bread. You flip it diagonally, so the middle part remains the same, only this part is gonna come to the bottom, and the bottom part is gonna go top. So this minus 2 comes to the bottom right here, 2 gonna go to the top. That's a transform. Now once we do the transform, it's gonna look like this. Okay, YT is what the one we derived, that is 1 1 minus 1 1 right here, and then the weight matrix remains the same. Now we do the multiplication, so you can see this is a 1 row 4 columns, so 1 by 4 matrix, and then 4 row 4 column, which is 4 by 4 matrix. These two are matching, so we can multiply, and this is going to be the output. And we do the same thing like before. We multiply this row by each column. 1 times 2, 2, 1 times 0, 0, minus 1 times minus 2, plus 2, and then 1 times 0, 0, plus 2, plus 2, that's going to make it to 4. Like that you do for each column. You get 4 0 4 0. If you have 0 or positive value, that replaces with 1. If you have negative value, that replaces with minus 1. Since we don't have any negative value, all of them are going to be 1. And if you look at this, this is x1. Okay, so we recall the x1. Now what we had to do is we had to bring this x1 and multiply by the weight and see if we are getting the y1. So x1 multiplied by the weight matrix. This is the original weight matrix. Again, row by column, 1 times 2, 1 times 0, 1 times 2, 1 times 0, and you add them together, you get 4. And you do for each column like that. So you get 4 4 minus 4 minus 4, and then positive values will be positive or 0 will be replaced with 1, negative value replaced with minus 1. So here we have positive 4 replaced with 1 1, and then minus 4 replaced with minus 1, minus 4 replaced with minus 1. And if you look at this, this is our y1. Okay, we recall y1. Now to confirm this one, what we do is we take the gh again, y1, and we multiply by the weight matrix transform to see if we are getting the x1 back. So y1 is 1 1 minus 1 minus 1, that is right here. And then we do the transform of the weight. As you can see, initial weight matrix, original weight matrix look like this. If you do the transform, the middle remains the same, but the top part will go to the bottom, bottom part will go to top. So okay, here we have a mistake here in this matrix right here. Okay, let me double check the original matrix. Yeah, the mistakes in the first one. Original matrix has a minus on the top, a plus in the bottom. So this, okay, I was looking at the wrong one. I should be looking at this. This is our W, and when we do the transform of this one, this is going opposite. Okay, this one was before. This one was already transformed. This is a continuation of this one right here. Okay, so this is this one right here is our W, and this is W transform. So as you can see, the 2 2 is this -2 go to the top, 2 go to the bottom. And then when we do we have to multiply this row by each column, and you get 4 4 4 4. If you have a positive or 0, or that is replaced with 1. If you have a negative value, that is replaced with -1. Since all of them are positive value, it all is going to be 1. And as you can see, that's our x1 value. So we recalled the x1 using the y1. Okay, so here finally we can conclude that here, hence in this problem statement, using the noisy vector xt, x1 is recalled first followed by y1. Okay, and that's our final answer. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.